Hello guys, and I am Paul McWhorter, and I am here to show you Arduino lesson number 3. Hopefully you enjoyed the first 2 lessons. If you haven't had a chance to look at those, please go back and review the material there, because the lesson today will be building on the first 2. In the last lesson, what we learned is we learned how to use the Arduino to control an LED. We learned how to use the Arduino to control an LED. And then also we learned to start writing a little bit of code in the Arduino. So we learned a little bit about circuits and we learned a little bit about code. We're going to build on that, and we're going to do a couple of things. We're going to make our circuit a little bit more complicated this time, and then we're also going to learn some new constructs in programming. And so we're just going to continue to build, and every lesson is going to build on the previous lesson. And when you look at this lesson, you should have a high comfort level because a lot of it is just reinforcing things that we learned last time. Plus, we're going to learn some new and powerful techniques that'll help you write better code and help you write more complicated programs. The basic assignment this time is, rather than blinking one LED, what we're going to be doing this time is we are going to be blinking 2 LEDs. We're going to have a red LED and we're going to have a yellow LED. And so the equipment that you're going to need for this project, again, that if you've gotten the SparkFun Inventor Kit, you'll have everything that you need in that. But if you don't have it, what you need as a minimum is you need an Arduino microcontroller. I'm using the Arduino Uno version 3. You'll need a red LED and a yellow LED. You'll need 2 330 ohm resistors. Remember, every time we use an LED, we need a resistor in series with it. You need some of these jumper wires, and you need a breadboard. And so it's pretty easy as far as the hardware goes, and we will jump right into it. Guys, on this video, I am going to sort of go step by step with you and let you watch me build the circuit so that you can continue to become more comfortable with the breadboard or the prototyping board. But in future videos, I'll just show you the schematic of the thing finished, and by the next video, I think you guys should be confident enough to sort of look at the schematic and build it yourself. But just in case you're not, I'm going to go ahead and go through the build with you on this one. So again, what we're going to do is we're going to have a red LED and we're going to have a yellow LED, and we're going to control them from the Arduino. And we want to control them independently. So in the first in the first 2 lessons, we basically just use one pin of our digital pins down here, pins 0 through 13 on the Arduino. So far, we've just used one at a time. We've got 13 pins, so we might as well start branching out and not being afraid to start working with more than one pin at a time. So in this video, we will be working with 2 pins because we want to control both LEDs independently. If we connected both LEDs to one pin or one voltage supply, then they would all be on together or off together. And we want maybe one to be on and the other to be off. We want them to work independently. And in order to do that, we're going to need to connect to 2 of the pins on the Arduino. Okay, I want you to kind of think about how you might be hooking this up, and maybe this would be a good time to sort of to pause the video and come up with your own strategy of how you would hook this stuff together to get the connections that are indicated in this circuit diagram. So one of the things we need to become comfortable with in engineering and comfortable with in computers and programming is going from a very abstract concept like this, the circuit schematic, and to go to something that is more concrete, which is this, that's more of a graphical representation of how we would hook the circuit together. Now, I've gone ahead and I've kind of done one here. You don't have to make yours look exactly like this. You can kind of hook it up like you like, but it should accomplish the same function. Now, there are things that are a couple of new things that I'm doing here as far as the hardware goes, that in the last circuit, when we were just connecting up to one LED, the ground pin of the LED, that shorter leg on the LED, I connected directly over here to the ground pin on the Arduino. Well, the problem is that as you start getting more and more components, all of them are going to want to be grounded, and so you are going to run out of ground pins. I think there's 3 ground pins. Very quickly, you're going to run out of ground pins on the Arduino. Everything always wants to be grounded. Every component is going to want to be grounded, and so what you need to do is you need to establish a ground rail. You need to establish a ground rail on your circuit board. And I have done this here in this diagram by bringing a wire from the ground pin to this top row. And for this circuit board shown here, it makes everything in that top row connected to that wire. So now any one of these holes, if I put a wire into it, I have access to the ground through this connection. And so usually you want to establish this ground rail for most projects, and so we might as well do it starting now, even though we would have enough grounds to run both of these LEDs on the Arduino. It's a good practice just to start by establishing a ground rail. Also, if you have more than one PC board, all of your grounds always need to be hooked together. And as I look at students' projects and there's problems in the circuitry, as often as not, it's that they have different components that they are not hooking the ground rails together on. So pretty much in a circuit, all your grounds need to be hooked together. Okay, so we've established our ground rail here, and then also what you see is that on the last project we had simply used pin 9 to control the LED going through a current limiting resistor. Well, this time we want to control 2 LEDs, and so we're going to need another pin. I just used 10. It's convenient. It's right next to it. And so 10 is going to come down and drive the yellow LED through this 330 ohm current limiting resistor. And then we've got this green wire that comes from the short leg of the LED over to this ground rail that we have established. Now, one of the things that I want you to take away from this is that as you're doing these things, you want to keep your wires as neatly as you can, and you want to keep your leads as straight as you can, and just try to keep this neat and organized, because with this view of components, it's not a big deal, but as your circuits get more complicated, they need to be really neat and really precise and thoughtful in the way that you lay the things out. There's many different ways that can work, but laying them out so that they're easy to see, easy to debug, easy to keep track of your wires is a pretty important thing. One other reminder is that the direction on these LEDs does matter. The long leg needs to be connected to the path that is going to the positive voltage, and so the voltage will be coming from pin 9 coming through the resistor, and so therefore the long leg needs to be the one connected to the resistor, not because it's a resistor, but just because the long leg needs to be pointing towards the voltage supply, not pointing towards the ground. The lower leg is what we point towards the ground. Okay, so just remember, a lot of times if your circuit doesn't work, a lot of times it's because you put your LED in backwards. If you do put your LED in backwards, it doesn't hurt it, it doesn't burn it out, but it won't work until you turn it around. Okay, so that's going to be our circuit there. And I think what I'd like to do is I'd like to just go ahead and try to kind of hook this up along with you. And please feel free to work along with me. You might want to even want to pause the video as we go through here and sort of keep track of what I'm doing. But I will try to keep both of these things on the screen at the same time. And let me even see. Yeah, I think this is gonna work good. Okay, so I'll try to get this sort of in the same orientation. And I like to try to work in the same orientation as my schematics. And so if you notice here, we've got the, this is the connector for the USB cable, as is this. And so I've kind of got that oriented the same. I'm going to try to get them laid out pretty much the same. Okay, and I got my 2 resistors and I got my LED. So I like to kind of start at one end of the circuit. And so the first thing I'm going to do is I'm going to establish that ground rail, because nothing's going to work if we're not grounded. And so I'm going to come over here, put that in, come down, and in this one, it's, let's see, this is opposite of that, but I'll go ahead and do it this way. I'll put it right there on the top row. So I've got the ground rail established on the top row. Okay, then I have another ground that's going to come from that top row. Okay, so this wire would be this one, and it's going to come around somewhere in the vicinity, let's just say right here. Okay, and I'm going to put it right there, and that needs to connect to that short leg. So this is right here. And remember, the short leg goes towards the ground pin, the long leg goes towards the positive, so that short leg of the LED needs to go there. Let's see if you can see. Long and short. Short is on the right, and so that's got to go exactly in that same column and then go over a couple of more columns. How many you go over is not exactly that important. You just need to kind of go where it's natural, like you see the LED popped in there very naturally without having to bend the pins. And guys, take care of your components. Don't bend your pins up. Put them in carefully, and don't let your leads get all bent up, because you'll want to use these components in the future, and also there'll be other people using the kits in the future, and you want to keep them nice and neat for them as well. Okay, so the next thing is, from the other leg, that long leg of the LED, we need to connect to a resistor. The resistor is a 330 ohm resistor. Remember, we don't trust that it's 330 ohms just because that was the label on the package we took it out of. We know that a 330 ohm resistor has the color code orange, orange, brown, and what I'm seeing here is orange, orange, brown on this one. I don't think it'll focus that close to really show you in detail, but I know this is the right resistor now. So one leg goes in that same column. It looks like I came down about this far here. One leg goes in that same column as that LED, and the other comes over just a natural amount, 3 or 4 columns over. Okay, and now that top of that resistor, this leg of the resistor needs to connect over here back to pin 9. And I even like to use the same color wires that I used on the schematic. And by using a red wire where I had a red wire, it's not that the color matters, but using a red wire where I had a red wire, the thing that happens then is that you can, it makes it easier to debug it later if you have a problem in the circuit. And so I'm going to come up here in that same column, the same column as that leg on the resistor. And so if you notice here, those are in the same column, so they'll be connected together. Now over here I have these in the same column, and I'm going to even see if I can zoom in on that and see if you can kind of see that a little better while we're working right here in that area. Let's see if that'll zoom in a little bit. Okay, that's going to be pretty good. So you can see right here is the lead, and then it connects right over there to the wire. All right, where does this wire go? This wire goes right back to pin 9. Why do I use pin 9? Just because I like pin 9. I could have used anything from 0 to 13 on this, but I like pin 9, so I'm going to use that one. And you could use a different one, but if you want to do it like me, you'll use pin 9. You know, guys, it's real easy to get these in the wrong things, so you really want to kind of eyeball it and make sure you're right above it, because it's very easy to get those pins off by, it's very easy to get them off by one notch if you're not careful. And I'll kind of try to zoom in on that and let you see it there. Okay. So you can see there that I am in pin 9. And then pin 9 does go to, I think I can just scoot that up and cheat a little bit. Then pin 9 does go to that resistor because it's connected in the same column. So we got that hooked up. We're well on our way. I think we pretty much got that first LED plugged in. Let's scoot over a little bit and let's start working on the next one. I usually just like to scoot over just a little bit so I leave myself a little bit of room, but you don't want to space it out too far because you'll run out of space on bigger projects. But I'll start by putting this resistor right here in, and I'll put the resistor right here and right here. Again, just sort of hopping over kind of a natural number of spaces where it fits in nice and neatly. And then it looks like I'm using a blue wire to go from the top of that resistor. So we're going to connect up here right above it from the top of the resistor. It's in the same column, so that's hooked up. And we're going to use pin 10. Okay, so I'm going to come over. The first one was 9. The next one is 10. Okay, now I've got my yellow LED, and the long leg, again, goes back towards the voltage supply, so the long leg would connect right there to the bottom of the resistor. Plug that in. Make sure you get it in there nice and good. And then you can see in the schematic, there is a green wire that goes back to our ground rail. And so I'm going to take the green wire, and I'm going to come back to the ground rail. All right. So now, hopefully you can kind of see that this circuit here is the same as what we've drawn here, or at least what is graphically represented in this circuit is kind of what we've achieved here. Now, I cannot promise you that I've not made a mistake somewhere along the way hooking it up. I tried to be careful, but don't get discouraged if you have a mistake in your circuit. It's called debugging. It's called troubleshooting. It's what you have to do. And if you don't have a problem on this one, you will have a problem somewhere along the way. And so you just got to get good at methodically going through and finding your problem. But at this point, I think that my circuit looks pretty good. And so with the hardware part of it done, we're ready to jump in and start doing some software. So I think I can go ahead and scoot that out of the way. And now we are going to start writing our Arduino code. One of the neat things is that when this pops up, it usually pops up with your void set up and your void loop already set up for you. What you know is that every Arduino program needs a void setup. Every Arduino program needs a void loop. The things that you put in the setup are the things that you want to do one time, like declaring your pin modes and things like that, things that you just do once, you do in your setup, and things that you want to loop through or do over and over, you do in your void loop. Okay, what we're going to do is we're going to start by declaring our variables. And in this case, we're going to use global variables. That means we're going to declare them at the top so that everywhere in the program it will know what these variables are. For variables that we would only use in one spot, like if we only needed them in the void loop, we could declare them down here in the void loop, and those would be local variables. But in this case, we're going to use global variables. Now let's kind of think about some of the stuff that we had to do earlier. And you remember on our earlier projects, one of the things that we have to do is we have to declare our variables. And so that's what we're going to do. And in declaring our variables, we need to start thinking about what variables we're going to need. Now, in our last program, we had one LED, the red LED, and we had it connected to pin 9. So up here at the top, we declared one variable, red LED pin, and we set it equal to 9. Well, this time we're using how many pins? We're using 2 pins. So how many pin variables or how many variables associated with the pins are we going to need? We're going to need 2, okay? And we need to name one of them like we did last time, and we need to say, kind of tell the Arduino, put a value there about where we're going to hook it up. So pins always come in round numbers. You're never going to have a pin 9.5. The pin is going to be 0, 1, 2, 3. So we need to declare that variable an int for integer. Later, when we start dealing with numbers that we're going to be doing math with, we'll use float for floating point numbers, which is sort of equivalent to, in your math class, real numbers. It's all the numbers that are in between the integers and everything else. But these, we'll use integers. Now, why not just make everything a float? I mean, why not make everything a float? Well, in the computer memory, integers take much less space to save. And so if anytime you can, it's a good practice to declare something as an integer. So we're going to have a pin, or we're going to have a variable that we call red LED pin, and we're going to set that equal to 9. Okay, and we're going to set that equal to 9 because we have the red LED pin hooked to pin 9. Now remember, you could call this variable anything that you wanted. Okay, you don't have to name them like I do. And there's nothing magic about red LED pin. You could just call it red pin, or you could call it red LED. You could call it what you wanted. But once you name it, you got to keep using that same name, and remember that the capitalization matters. Okay. So I'm going to introduce one new concept here. As our programs start getting more complicated, we need to start keeping track of what we're doing, and we need to start documenting our code. And basically, the Arduino lets us put comments in that are only for humans to read. It's only for us to read. The computer doesn't read it. It doesn't do anything. The Arduino doesn't do anything with it. And the way we get a comment is we just put 2 slashes like that. That's the forward slash. 2 forward slashes, and that's telling Arduino that this is just a note to ourselves. It's not anything that the Arduino needs to use or look at. And what I just remind myself that what am I doing here? I'm declaring red LED pin as an int. So I'm just saying this is what I did and set it to 9. Okay. Now, what would be the other thing that we've got 2 LEDs? What's the other one? Well, we need a variable for the other LED, and we're going to call that an int as well. And what would this be? Well, it would make sense to call it the yellow LED pin. And what did we hook the yellow LED to over here? We hooked it to pin 10. Remembering that we always end in most all lines in an Arduino program with a semicolon. Okay. Here another comment declaring yellow LED pin as int and set it to 10. The nice thing about documenting your code is that if somebody else comes in and looks at your code, like if your teacher looks at it or something, they can come in and or a friend looks at it, they can come in and they can understand what you're trying to do. If I just start throwing variables out, nobody's going to understand what I'm doing, but by putting some comments in there for the humans, it helps the human understand what you're doing. Now remember when we were blinking the red LED, there were two parameters that we needed to define a blink, and that is sort of like in the blink how long it's on and how long it's off. Because if you're going to blink an LED, it's on part of the time and it's off part of the time. So remember how we had an on time and we had an off time? Well, we're going to need an on time and an off time. But if you think about it, we might not want to blink the yellow LED with the same parameters as the red LED, and so probably I think we should use 4 variables: a red time on, a red time off, a yellow time on, and a yellow time off. So let's use 4 variables this time. And so the time is in milliseconds, and milliseconds work very well as integers, and so we will declare it as an int, and I'm going to go red on time equals, let's say, 1/4 of a second. So what number would we want to put here for 1/4 of a second? Well, it's measured in milliseconds, 1,000 milliseconds in a second. So 1/4 of a second would be 1/4 of 1,000, which would be 250. So we're going to leave the red on for 250. And then let's come over here and say this is the red LED on time. Okay. Integer red off time. And we're going to make that 250. So it's going to be on for 1/4 second, off for 1/4 second on the red one. Really be really careful with your capitalization. Again, I'm using this bumpy font because it makes it easier to read where the first letter of each new word I make capitalized, so you can sort of see how the words go together. But the capitalization matters if you don't use exactly the same capitalization. You don't have to capitalize like I do, but whatever you're doing, you got to do it exactly the same way every time. Okay? And so we're going to say this is the red off time. Okay? And then similarly, we're going to have integer yellow on time. We're going to set that. I'm going to make them the same. I can change them later, but I'm going to make them the same right now. Don't forget your colon, // This is the yellow on time, and then integer yellow what? Off time. And that's going to be 250. All right. Okay. This is the yellow off time. Okay. So with these, what do we have? 6 variables. 2 of the variables tell the Arduino, are going to tell the Arduino which pins I'm connecting to in the circuit, and the other 4 are parameters: how long the red should be on, how long the red should be off for a blink, how long the yellow should be on for a blink, how long the yellow should be off for a blink. And so these 6 parameters are going to go a long way of being the variables that we need. In the void setup, you can see here, this is just a comment. You put your setup code here to run once, and we don't really need that comment. So what do we need to do in our void setup? Remember, anytime we're going to use a pin on the Arduino, anytime we're going to talk to one of these pins on the Arduino, we've got to tell the Arduino whether we're going to be talking to it or we're going to be listening to it. And in this case, the Arduino is going to be sending out a voltage, so it's going to be an output pin because we're sending something out to it. Okay, and so what we're going to do is we are going to make a pin mode. Remember, the M in mode is capitalized, and kind of what's neat is you see that it turns orange when you do it, right? So let's just imagine I did it wrong and I said pin mode. You see, it doesn't like that. If I put it in right, it turns red. And so if you pay attention to the colors, it sort of gives you a clue that you made a mistake. Okay, we're going to do red LED pin. And then that is what type of pin. We want it to be an output. Notice how output sort of turned blue, tells me I spelled it right, and every line ends in a semicolon. Okay, so that was pin 9. Now we're going to do pin mode, and then we're going to do the yellow LED pin. What do we have the yellow LED pin hooked to? We have that hooked to pin 10, like that, right? No, 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 do not put constants in your pin modes. Always use the variable. That's why we set it up here. We're going to set the pin mode to yellow LED pin. And it knows what yellow LED pin is. It knows it's 10 because we told it up here, but don't put 10 in here. When I grade your code or when I come around and look at it, I'm going to count off if you get lazy and start putting constants here instead of using your variables. And just like the red, it is output. Ooh, wait a minute, what's wrong? It didn't turn this orange. Oh, look at that, I misspelled pin. I spelled it pint, so let's fix that. Now look at that, everybody's happy, so that's good. Okay, so now we're all set up and we are ready to start writing code here, okay? So how do we turn that pin on? How do we turn that pin 9 on? Like if we want that LED to turn on. Oh yeah, and let me just kind of tell you what we're trying to do here. We're trying to create, I'm just going to make something up. We're trying to create a program that will blink the red LED 10 times and then blink the yellow LED 1 time. So I want 10 reds and 1 yellow, 10 reds and 1 yellow, 10 reds and 1 yellow. And so the void loop needs to blink the red LED 10 times and then blink the yellow LED 1 time. And you'll see in a minute why we're doing this is because it's a way to introduce some new code. But for right now, let's just do this the way that we know based on what we know. Well, how would I turn the red LED pin on? I would say digital write, okay, and I want to write which pin? The red LED pin. Okay, I got to tell it where I'm going to write. I'm going to write to the red LED pin, which is pin 9. And then what am I going to do? I want it to go high because I want it to turn on. Okay, so then I'm going to come in and I'm going to put my comment in. Again, / tells it a comment. Turn the red LED on. Very good. Okay, now it's on. Before I turn it off, I've got to wait. So what do? I delay how long? Well, I want it to be the red on time. Okay, red on time. And what that means is it's going to stay on for however long I delay here. So I delay red on time, it'll stay on that long. Now I want to turn it off, and I say digital write red LED pin, and what do? Low. Low will turn it off. Okay. And now after I turn it off, I better put a delay in here. It'll turn right back on. So I got to leave a delay, and I delay it by delay red off time. Okay, like that. And so it's going to turn on. Wait half a second, turn off, wait half a second. So it's going to sit there and it's just going to blink like that, okay? Now, one of the things I want you to see that I've done here that's, I think, a good coding practice, Arduino does not keep track of white spaces. Arduino ignores white spaces. Some programming languages like Python, they care about the white spaces, and you have to do the white spaces perfectly. But I like to indent my code even though Arduino doesn't look at it, because like if I look at my void setup, I have all this indented, so it's easy for me to see what's in the void setup. It's easy for me to see what's in the void loop by kind of doing this indentation, and I suggest that you do that. One of the things I also like to do is I like to kind of run my code as I go so I can sort of find my problems early on. And so I don't want to just go ahead and run this, even though what we want to do is we want to blink it 10 times and then blink the yellow one 10 times. I want to make sure that my code is working so I don't get too far into this before I figure out that I've made a mistake. So let's go ahead and do this. Okay, I saw a lot of green down here. That means everybody was happy, didn't get any orange. And look at that, that LED is blinking on for a quarter second, off, on, off, on, off, on, off, quarter second each, just exactly like we told it to, okay? I got a little sloppy here and I was not remembering to put my comments in. Let's go back and put our comments in and say turn the red LED on, okay? Wait, and then what do we do here? We turn the red LED off, and then again we wait. And so this is just good practice to put your comments in here so people can see what you're doing, or if you come back later you can see what you're doing. It's always good to put those codes in there. All right. Now the thing is that the reason this continues to blink is it continues to loop. But if I want it to blink 10 times and then blink the yellow one, I've got to put this in here 10 times to blink it. Now I guess there's two ways we could do that. One way that we could do it is that we could just go in and we could retype this 10 times, but I think I'm going to try to cut and paste and see if that'll make it a little bit quicker. So I'm going to copy it, and I want it to blink 10 times, and I already have 1 in there, so I probably need to paste it 9 times. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I wasn't paying attention, I didn't copy real good, and I just like neat code, so I'm going to take that extra space out before the D, just because I find if I keep my code neat, it's a lot easier to find the problems. Also, like if you're a student and you want your teacher to look at it, or you have somebody looking to help your code, help you figure out what's going on in your code, if your code is in a big mess, they're not going to be very eager to help you. But if your code's nice and neat and well documented, you're a lot more likely to get some useful help from someone. So now if I run this, it's not going to look a lot different because we haven't done anything different. But if, ooh, I erased my D there. I better put that D back in there. I erased the D instead of the space. Okay, here we go. Let's try. Everybody's happy. We got the green here. And if we look down here, we are going to see a nice blinking red light, I bet. I hope. It's a little bit slow here to download. I am not sure why. There it goes. It did not like. Okay. Not exactly sure what is happening here. Okay, everybody's happy. All right, and there it goes, it blinks. I'm not sure, it just got a little glitch on the download that time, and that happens sometimes, but sometimes just try it again. Okay, so this is all working, and the LED is blinking 10 times and then repeating, blinking 10 times, repeating. Well, what we wanted to do is, after doing this 10 times, we then wanted to blink the yellow LED. So now we go blink 10 times on the red LED. Now we need to blink the yellow LED. So we come in here and we say digital right. Okay, and what pin was the yellow LED connected to? It was connected to pin 10, so we put a 10 in there, right? No, do not put constants in there. Remember, we made a variable called yellow LED pin. Okay, we're going to tell that high. And let me think about this. Like, imagine now if I wanted to change and connect the red LED to pin 8, all I would have to do is just come up here and say 8 and then move it over. If I had put constants in here, I would have to come in on every single one of these and change it. And then anytime you change it, you increase the chance you're going to make a problem. And so you can see by using this variable, it makes it much easier to change. Okay. So now we're going to come in here, and this is going to turn the yellow LED on. And then we're going to delay by how much? By the yellow on time. Okay, and then this is basically what we're doing is commenting here, wait, and then we're going to digital right, yellow LED pin high. Ooh, let's look at this. Why did this not turn blue here? These other ones, look at that. It needs to be capitalized, and I didn't capitalize it, so let's fix that. Okay. I try to make these mistakes just so that you'll sort of have seen them when you make them, because believe me, you will make mistakes like that. Okay, now we were going to wait here. We were going to turn it low. Okay, so we turn it on, we wait, we turn it off, and so turn the LED off. Okay, and then delay yellow off time. Okay, and then we're telling it that we are going to wait. Okay, now understand what we write out here. Again, I've said this before, but you really need to understand what we write out here past these hash marks, these slash marks. The computer doesn't read that. That's only for us to remind us of what we're trying to do. Okay, now if I have this hooked up right, this time it should blink the red LED 10 times, and then it should blink the yellow LED 1 time if I hooked it up right. So let's see. First of all, did we have any errors? Oh, we got an error in the code. Error in the code. What does it not like? It doesn't like yellow off time. And so what did I do wrong there? Yellow off time. Yellow off. You guys might see it before I do. YELLOW-OFFTIME. Here we have YELLOW-OFFTIME. I am not seeing my mistake. Let's try it again. Yellow off time was not declared in this scope. And so what that means is that there is something different about how I wrote yellow off time here versus how I wrote yellow off time here. And so when that happens, one of the things I sometimes do is just come up here and copy that to make sure I get it exactly the same. Ah, I see. I capitalized the Y here where I didn't capitalize it initially. Okay, so you notice when that happened, that'll happen to you. Don't panic. It's just you made a mistake. Just find your mistake. Something isn't exactly right. Just go in and find it. So you see I didn't capitalize it right. So this time it is going to work. It's green down here. Everybody's happy. Boom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 6, 10. Okay, look at that. That looks good. Yeah, I was just counting. It is, it's a little hard to count, but it is working correctly. So the red one blinks 10 times, and then the yellow one blinks 1 time. And the neat thing is it's doing exactly what we told it to do. It is blinking exactly in the sequence we told it to do. It is just going through this program line by line by line, and it is doing exactly what we told it to do. And so this is a great day. We got our circuit hooked up right. We got our code written. Everybody's happy. Everything's running great. Okay, now this is the problem with what we did. It works, but it's not the best way to do it. Imagine if I told you I wanted you to blink the red LED 25 times or something like that. I wanted to just really go in there and do something crazy. And the problem is, do you see how it's kind of hard to count these things? I try to make it as easy as I can. Do you see not only do I put a little indent here, but I put a space between the blocks so I could sort of count like 1, 2, 3, 4, 5, but it's hard to count scrolling code like this. So you really need a better way of doing it, okay? You need a better way of doing it. And so what I'm going to do is, basically it's this one thing here, this one block of code we want to repeat over and over and over. So I'm going to get rid of these other 9 times that I told it to do that, and I'm only going to keep 1. Okay, because what I want to do is I want to loop through this code 10 times, and then I want to loop through this code 1 time. Okay, so rather than type this code 10 times, there is something that we can do in Arduino and in just about any programming language or in all programming languages is we can make a loop. Just like this is a big void loop that's always there, we can make our own loop. But the type of loop that we're going to make is called a for loop. And a for loop will loop through the code the number of times that you tell it to. And the way it works is you create the for loop saying for, and you see how it recognized the word for because it put it in orange, meaning, hey, I know what that means. I've seen that before. We're cool. You see? That's what it means. That's what it's saying when it turns out orange. All right, and then inside here, we're going to put some condition and some parameters. Don't write conditions, but that's just what we're going to put in there. I'll get to that later. So the conditions go in there, and then where does the for loop begin? A loop or a clause always begins with a curly bracket, and it ends with a curly bracket. So we need to come at the end of the loop and say, between those curly brackets is the for loop. Now you got to kind of keep track here because now we're getting loops inside of loops. And one of the things I can do is if I click on this closed curly bracket, it shows that it goes with that curly bracket. So when I do this, that is the for loop from here to here. Now the void loop is this outside loop which goes all the way through there, but we're not concerned about that. We are working on our for loop here. So this for loop is going to loop through the segment of code that starts with the open curly bracket and ends with the closed curly bracket. All right, and so you got to keep track of your curly brackets, and a lot of times when I see errors in code, it's because you aren't closing off your curly brackets. And so one of the things I do is, let me take this out here for a second. I'm just going to cut that. Okay, when I make a for loop, okay, I've just made the for loop. I open my curly bracket, I come down a few lines, and I close my curly bracket right there, and then all my business I do in between this curly bracket and that curly bracket. If you start writing a bunch of intense code in here, I promise you, you're going to forget to close your curly bracket. So when you make your for loop, go ahead, have it start and end right there before you put any code in. Now we can come in and we can put that code back in. Okay, and this is the code that it would take to blink one time. And so how many times do I want to do this loop? I want to do it 10 times because I want it to blink 10 times. So this is the way you do it. You've got to create a counter. Now I could declare the counter, and usually what you use for a counter is the letter I or the letter J. For some reason it just started way back in the day, and so a lot of times the variables that you use for a counter are I or J, but you could use anything that you wanted. Now if I were going to do that, I could come up here and I could declare a variable int I, and then I could say this will be my counter. Okay, but this is a case where you really don't need a global variable. It might make more sense to make that a local variable, and so we're going to make that a local variable by declaring it down here inside the void loop. And in fact, we can actually declare it inside the for loop, and we would put it right here. We're going to have the variable, and I think, I'm going to make it J, integer J. And so inside this condition of the for loop between those two parentheses, I'm going to say J equals 1. That means the first time that I go through the loop, J is going to be equal to 1 because I tell it start with J equal to 1. And then the second part of it, after a colon, semicolon here is, you tell it how long to loop. I want you to loop as long as J is less than or equal to 10. And so this thing will continue to loop as long as J is less than or equal to 10. And then the third thing that you put is, what do you do to J every time? Well, every time you go through the loop, J is going to be equal to J plus 1. And so every time you go through the loop, J is going to increment by 1. And so let's just kind of think through this. You get to this loop, and then you're telling the Arduino, I want you to do a for loop. I want you to start with my counter J equal to 1. J is an integer. I want you to continue to loop as long as J is less than or equal to 10. And then every time through, I want you to increment J by 1. So the first time through, what is J equal to? It's equal to 1. Then the second time through, you add 1 to J. J is equal to 2. Is 2 less than or equal to 10? Yes, it is. We're going to go through it again. So J is equal to 1, J is equal to 2, 3, 4, 5, 6, 7, 8, 9, 10. And this time, JJ plus 1 is equal to 11. That's more than 10. It pops out and it doesn't do it. So this will do it 10 times. It will do it for J equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it will pop out and come and do whatever the next thing is. So it goes through this loop as long as J is less than or equal to 10. Now understand, you could use a different variable. You could make it I. Why do I not use I so much? Because most of the misery in my life has been associated with using I as a counter, and look how much I looks like 1, and so it's very easy to get a typo where you can use I and 1. So I just like to use J because it doesn't look like a 1, and it's easier to decode, or it's easier to debug when you have problems in your code. So you could start at 10 and go to 20, and it would, or you could start at 11 and go to 20. This is the starting J, and then this you loop as long as J is below this, and then every time through you make J is equal to J plus 1. Okay, so this is going to go through it 10 times. This is a for loop. A for loop is one of the most powerful things that you can have in programming, and it's just an incredibly powerful concept because you see, look how much easier this code is than the earlier code that we did. It is so much easier. Let's hit it and see what this does now. Okay, it downloads, it's happy. 1, 2, 3, 6, there it goes. Boom. And so you see that the program is still working. It loops 10 times, and then it lights the yellow one once. Okay, so what's one thing, this is really cool, this has made it a lot better. What's one thing that maybe would make this a little better? There's one thing that I don't like about what we did here. I don't like how we came down here and made this a 10. Well, what if I only wanted to loop 5 times? I guess I could come down here and make that 5, and then I could download the code again, and then come over and watch this. It'll take a second, and then 1, 2, 3, 4, 5 yellow, 1, 2, 3, 4, 5, and then the yellow. Okay, so you see this is working, and you can come down and change this to make it go. But I never like to change code down there in the guts of it, right? It's a lot better. Remember, I don't like using constants down here. So how could we get rid of this constant? Why don't we make this num red blink? So this is the number of times you want the red to blink. Well, if we're going to use this down here, we've got to declare it. And so we're going to come up here. If we're going to use the variable, we got to declare it up here, integer. And that is going to be num red blink. Okay, and let's say that we're going to make it blink 3 times. Okay, so I put the 3 here, and then it always will blink however many times I say. And so let me continue to be a good boy, and I will put number of times to blink red. Okay, so what we have now here is we have a variable set up where the way we can control the parameters down the program is just playing up here and not getting down in the guts of the code. So let's download that and see if it works. Okay, look at that. 1, 2, 3, blink. 1, 2, 3, yellow. 1, 2, 3, yellow. You see, that's kind of nice because now I don't have to get down here and get confused about what's doing what. I can do all my controlling up here. Let's see if we can make it blink like faster. So let's say that I'm going to go, or let's just make it do different. Like I want it to stay, I want it to be a short blink. So I'm going to have it on for 100 milliseconds, and I'm going to have it off for 900. So the red, I messed that up, didn't I? No, that's right. The red is going to be on for 100 milliseconds, that's 1/10 of a second, and off for 900 milliseconds. So it's going to be on for 1/10, off for 9/10. And then on the yellow, let's do it backwards. Let's have it mainly on. So we'll say it's on for 900, and it is off for 100. And then let's have it blink 5 times on the red. It's downloading, everything's green, everybody's happy. Okay, let's see if it's going to work. Okay, the yellow stays on. You see the red's just blinking very shortly. The red's mainly off, blinks 5 times, and then the yellow has a long blink. So you see these things are behaving exactly the way that we told it to. So that's pretty cool. And now I can just control things from up here. All right. Hopefully you were able to follow along with me. What I want you to do for your assignment is I want you to create another for loop and have the yellow blink inside of its own for loop. I want you to have the yellow blink inside of its own for loop, and therefore you're going to have to have another variable up here, num yellow blink, and that way up here you could say blink red 10 times and yellow 10 times, or blink red 1 time and yellow 10 times. And so then you're going to have complete control of both of these LEDs from up here. Okay, be sure to check out my website, toptechboy.com. I have the source code, I have diagrams, I have all the information, as well as the sources of equipment that you need for this project. Be sure to check out the blog, and be sure to be waiting for lesson 4, which will be coming shortly. Talk to you guys later.